Well, this is a view from in front of the camera using our green screen rig here at the shop. We often use this green screen when we're doing product reviews or quick repair tutorials, and it's very useful for doing quick shots and just leaving this set up in the corner and using it for better quality videos. We have all the necessary lights, and it's fun to make green screen once in a while, even though it does take some time. The problem with this setup that I have anyway is you need a helper to run this. This is definitely at least a two-person job. You need a person behind the camera, such as I am now, and then you need a person to operate the rest of the equipment while the recording is going on. And that brings up our next project. I thought it would be really neat if I was able to control the camera from behind the camera, or in front of the camera rather, using an Android tablet from sitting right here wirelessly. So if I was able to make that camera move up and down or side to side, and then I had a monitor like that one over there to show me what I looked like when I was standing here in front of the table, that'd be great. So that brings up my next little project. I'm going to make a pan and tilt head for a camera mounting system that will be useful to line yourself up when you want to film yourself, or for remote applications where you might have a security camera on a pole or in an airplane or whatever, where you cannot reach the controls directly but you want to still control the view. Okay, so that's what we're going to do. I'm going to try to use a Raspberry Pi, some servos, and a little bit of luck. Maybe we can make a camera move up and down on a tripod automatically, and I can film my own videos coming up on this edition of the Guru Brew. Well, I got a package in today from Adafruit, and this is the 16-channel 12-bit PWM servo driver. It's the 12C interface, and I'm going to open it up here and take a look at it. I received a few other things from Adafruit too, such as these jumper wires, so I can experiment with the Raspberry Pi some more. But this servo driver interests me in the fact that I'm going to use it with the Raspberry Pi. This could also be used with Arduino, or any development computer really. And I plan on building a platform camera support that is automated, that we'll be using here on the Guru Brew show, and I'll get into that more in a minute. Let's just take a look here at what they've sent me. You can see it's 16-channel 12-bit, and there's a little bit of soldering here required. There's the actual board. And then here's the headers that they sent that need to be put into place. Just dry fit this together here. So this would be your power block here, and it's marked with the ground. And then these are the PWM servo connections here. And there's a signal for the PWM on the top here, this whole top line going across here. And then the middle is your voltage positive, which will be put in separate from this power on the board, because the servos will draw too much, more than the Raspberry Pi can provide. Now this does have 16 channels, but from what I understand, you can use many more than 16. So you can see how these solder in, just like that. And then there's a header pin for the board control that comes from the Arduino or the Raspberry Pi in my case. Now the interesting thing to note, and I don't see any notes on it, is both of these sides seem the same. So I'm thinking you can use one or the other for alternative. We'll check that with an ohms meter in a minute, but I'm pretty sure that you know, if you wanted to use this side or this side, you could just switch it either way. So it's a pretty nice looking little board, and we'll get soldering it up in just a second. I just want to check this, make sure that each side is the same. And voltage plus. So yeah, the pins on the left are the same as the ones on the right, and you know, it's perfectly acceptable to use either side, depending on what side you want to hook your Raspberry Pi to, I would assume. I'm just going to go ahead and hook it to the left side here, though. If you're wondering what all the noise is, I'm slowly growing my little solar farm of animated characters here. A whole bunch of them going here. These are exactly $1 each, and every time I go to the dollar store and I see one, I'll pick one up. I think it's amazing that you can buy these for $1. I honestly don't know how they do it. But if you remember the video I did on the little solar dancing girl, well, guess what? They come out with a solar dancing girl, and here she is. I was happy to see the little girl, but at the same time I was kind of mad because I thought of it first. Anyway, they're really cute, and I collect those now. Okay, let me get my soldering iron fired up here, and we'll get putting this board together next. Okay, so I have my little soldering iron here plugged in, heating up. Just gonna go ahead and put this little Adafruit servo controller here together. I'm going to start out with this power connector here. I think I want the wires to come off to the side. It doesn't really matter how you do it, as long as you're respectful of the polarity when you go to hook it up. But if you put it like that, you're going to be bringing your leads in over this chip. I don't think that's a good idea. I'd rather bring the leads over the top like this. So we're going to put it just like that. You start with a clean tip on your soldering iron with my little dollar store pad here that cleans the tip off very nicely. It's just a scrubber pad, almost looks like a copper or something that I just took the handle off. Works well. Okay, now I'm going to put the header on, and like I was saying earlier, it doesn't matter what side this goes on. I'm going to go ahead and run it off the left side here though, but you could certainly run it off the right as well. So it's a pretty simple little kit to put together, and even if you're not really experienced with soldering, it shouldn't be a problem. Something I like to do is get an old toothbrush when I'm all done. This isn't a toothbrush, but just to demonstrate, and clean right in between here, and then even get a magnifying glass and look in between here to make sure that nothing's touching, that you don't have any solder bridges. Okay. For the project that I have in mind, I'll probably only be using 3 servos total. but you know, I'm going to go ahead and put all the connections on in case I change my mind later. So I'll have the ability to put 16 on at any one time. And I was reading on the Adafruit website, and these can be chained together, and you can run hundreds of servos all at the same time, which is pretty cool. Okay, I'm going to show you what I was thinking about using this tripod tilt system for. Oftentimes when we do green screen work here for YouTube videos, here let me demonstrate. We have a green screen back here. We use green for that. So we have a screen. Oh. There's our green wall. And then oftentimes it'll be me that's in front of the camera, so I'll put myself right here looking this way. And then I usually have a table or something in front of me, so that'll be here. And the problem is the camera is generally here. Okay? And I have to have a couple lights here and here that illuminate me and the screen here. I have to walk around to adjust the camera. Then if I want to stop, I got to walk back, and then I've got to keep readjusting this camera or get a helper. And oftentimes I don't have a helper, so I'm able, you know, I have to wait until someone can help me. And what I was thinking is, if I had this on a tripod that had a tilt and pan head, so I could move it up and down, or you know, left and right automatically with a device. And I was thinking about using an Android tablet with an app on it that runs off the Raspberry Pi. So if I'm able to use the Raspberry Pi with my servo controller that hooks to the servos that are mounted on the tripod, I can pan and tilt the camera from, you know, an Android tablet behind the table and never have to move out of the chair. And I can actually set up a monitor over here that's hooked into the camera and monitor to make sure that, you know, everything is centered in the camera before I hit the record button. So that's the idea behind the motorized pan and tilt system, and that's the reason why I'm working on the servo to be run with the Raspberry Pi right now, so I'm able to also access it through the Android system. So that's it for now. Well, because I have flown airplanes and used remote control cars, I have a collection of hobby parts here that go into airplanes and cars and that sort of thing, and they're servos. And here's a box here that I have full of servos, and these are not digital servos. Digital servos have been out for a little while now. I don't really require the precision of a digital servo. These are just analog, but they take about 5 to 6 volts to move. They have a signal line, then they have a plus and minus, and there's all shapes and sizes. You can get ball bearing type servos or just standard servos, and they're measured in torque. I had mentioned on my stepper motors on my CNC, they were also measured in torque. Well, these are no different. And I don't know if you can see that there, but they rate these at 4.8 volts and 6 volts. And the more volts, of course, the more torque that you get. This one is rated 46 ounces per square inch at 4.8 volts. So I'm going to go ahead and grab some of these servos, and we're going to start putting this Adafruit servo driver together. So hang out for that. Okay, well, I have a collection of parts here on the table that I plan on using. This is the board that I just got through soldering earlier. And I bought some of this ribbon cable. It's not really ribbon cable, it's a male and female jumper cable. You can see the male on one end and the female on the other from Adafruit as well, and then you just peel off what you need. And I just started wiring this up. You can see where I took 6 of the wires and just put it here on this jumper, and then it comes up to here. And this could go directly into my Raspberry Pi on the GPIO pins if I wanted, but I'm using this other new thing that I got from Adafruit. It's called a Pi cobbler. It's right here, and it came with this ribbon cable. So instead of, bringing these wires over here into my GPIO pin, I can use this ribbon cable and test things out before I commit to it. And then of course I can get rid of the cobbler, which is this board, once I figured out what I want to do here. So the Adafruit website is very good. This is the actual 16 channel bit 12-bit PWM servo driver that I purchased from them. You can see I paid $15, which is a really good deal. And so far I'm very satisfied with the specifications and the way that they've presented these products. They've got technical details as well as tutorials, downloads, and they have quite a bit of information, so they're very well supported, and they do give you enough tutorials and that sort of thing to at least get you started with Python. So I've just been looking down through here and double checking my wiring, and they pretty much told me what pin goes where. Such as the brown one here is on ground. You probably won't be able to see this, but those pins are actually marked, and then I just followed it up to ground here. And really only 4 of the 6 are hooked up right now, so the only thing left to do is I need to hook some servos on these pins. Now for the project that's coming up with a pan and tilt head, I probably will only use 2 or 3 servos, but I'm going to go ahead and just hook these ones up that I just grabbed. You also have to install a bit of computer code for the Raspberry Pi, and that's on the Adafruit website too, and I'll put a link on there so that your Raspberry Pi is set up and ready to go. And these pins are all marked which way. This is servo 0 and this is servo 15, so you've got 16 servos on this one little board, and the ground pin goes towards the bottom on this one. And if you look on servos, there's always usually a black wire, and then a white would be signal, red would be positive. And you can see on this one there's a brown, red, and orange. So brown on this one would be the ground, orange would be the signal. So different servo manufacturers are going to have a little bit different specifications as far as which one is the signal and which one's ground. So you can just look on your servo box if you're not sure. I'm just going to go ahead and hook all these up with the ground at the bottom. There's 3. There's another one. Okay, so that should be enough to test. We have 4 servos here. And now the power for the servos is separate from the power for to drive this board. That's what this connection is here. And I'm just going to use this 6-volt battery pack for that, even though my final will be probably rechargeable batteries. These are just regular ones. And the board's marked which one's ground and which one's positive. Should have probably waited to put that battery in. Ground in. So I managed to get a servo working from the Adafruit site that had a demo program written in Python. And like I was saying earlier, it's a very good site, and they have very good coding tutorials. So this is very doable for someone with even no experience. If you can read and follow directions, I think just about anyone could do it. And you can see that I've remote desktoped into the Raspberry Pi through this Windows machine on the screen. And I'm just using the command driver to execute this test servo example from the Adafruit library, and it seems to be working good. It's just cycling this servo, and I'm sure that the other pins will work just fine. I'm gonna spend some time and try to play with Python and see if I can't modify this test code so that I'm able to access this through maybe a PHP script inside a web server. So I'll be back for that. That's coming up. Okay, well, all the electronics seem to be running, so it's just now a matter of writing some code that we can control through the use of a tablet, such as this Polaroid tablet that I reviewed on another video. It's an Android powered, and the other part of this would be the hardware for the tripod mount, and this is something that I drew in SolidWorks, and it would be a camera mount that would be mounted to this arm, and then it would raise and lower by a servo here hooked to the left arm. You can see it inside there. Anyway, that would raise and lower, and then to pivot the other way, you can see the other servo here on the bottom, and it is connected to another base, and then of course, you know, this whole thing can pivot. And I've got that locked down right now, so I can't show you the pivoting. I think I'm still not quite satisfied with this model. I'm going to, you know, play with it some more. This is based on the servos here, these Fatabas, and I used the drawings for the servos from the Fataba website. So this is a S3003 servo, and I think these are only about 10 bucks a piece, but anyway, that's what we have here. So if I want to change the servo to a Metal Gear or something like that, I think the casing's very close to this one. And then, you know, I did some little features like right here in the back, this would be for the wire escape. So when the servos are sitting down on this hole, you know, the wires need to escape out the back. And this is all going to be light plywood construction. And we'll just build a prototype after I get these electronics done for this Raspberry Pi and see how it works out. So hopefully, if all works out, I'm hoping to move this thing automatically up and down just by using this Polaroid Android tablet. Okay guys, well that's it for now for the pan and tilt tripod head for our Raspberry Pi powered tablet moving thingy. I lose track of what we're making after a while. Anyway, if this product works out in the end, I can see some great uses for it and maybe even put it up on public domain for other filmmakers to use its design. I think it could be something very useful to filmmakers. And not only that, but I think you could also use it for maybe model applications, size down. You know, you could use it in an airplane, a model airplane, to pan and tilt your view live. You could use it on cars, that sort of thing, maybe a robot. Okay guys, I'm going to leave you with that. Me and my boy have some learning to do as far as Python. I need to create a PHP website that is Apache driven through the Raspberry Pi, and I haven't done that yet, so that'll be a little learning lesson. And just some miscellaneous things, and I'll film the whole time I do them so you don't miss on the action. I hope you're enjoying these videos. I know I'm a little off the wall, but I make things that I like to play with, and that's how I make my videos. If it interests me, I'll build it. So that's how I work out. So let me know in the comments. And that's it for now, guys. Thanks for watching. Bye. Hey guys, this is Steve. Thanks for watching. Hey, don't forget to subscribe if you like this video, and be sure to rate and comment. See ya.